Hello, students. This is AQA Energy Unit. This is the first lesson of the energy unit for the GCSE Physics, entitled Energy Stores and Conservation of Energy. Right, before we start our lesson, I would like you to look at these pictures and predict what energy types they are. The first one is a battery. What type of energy is stored in batteries? The second one is a nucleus, an atom. What energy is stored in an atom? We have a light bulb. Can you predict what energy is being exhibited from a light bulb, or what comes out of a light bulb? And then we have the Earth as well. What energy keeps the Earth in orbit? We have a catapult. What energy is stored? Food. What energy is in the food? And then we have a car that is in motion. Right. So the cell produces electrical energy, but it stores chemical energy. It is the chemical activities in the cell that releases the electrical energy. And then the atom has a nuclear form of energy, which is stored in its nucleus. The light bulb produces light. The thermometer is very sensitive to heat. The Earth is gravitational potential energy. We have sound. The car, moving car, has kinetic energy. Food like burgers, they store chemical energy. Any food stores chemical energy. Any fuel stores chemical energy. Any fuel that you talk about or any food is chemical energy. Okay. And then we have the catapult, which stores elastic potential energy. By the if you are able to go through this session, you should be aiming at grade 8, where you can explain the factors that affect the size of the changing changes in energy stores. If you're aiming for grade 6, you should be able to describe the energy changes in terms of the processes. And then you should be able to use graphs to explain the energy stores, accounting for the different changes if you're aiming at grade 8. So the first thing is, what is energy? Well, energy is a common word that is used at home, it's used everywhere. But what is it? If you watch a Road Runner cartoon, what example of energy type you can identify? Basically, energy is the ability to do work. Energy is the ability to do work. So when you work, you've transferred energy. So work done is the same as energy transferred. Work and energy goes hand in hand. When there is work, energy will be present. Basically, you're going to be transferring energy in order to do work. So work is energy transferred, whereas energy is the ability to do work. Energy is measured in joules, okay? That's the unit for energy. If you have 1,000 joules, it's called a kilojoule. If you have a million joule, it's called a megajoule. If you have a trillion joule, it's called a gigajoule, and it carries on and on. So energy store, if you look at the pizza, it stores energy. What energy is stored in there? The energy stores in there is what makes the person to do some work by running. Okay, the person running needs the energy from the pizza in order to make him run. So we use energy to do work. Okay, we use energy to do work. When we eat, our body transforms the food into energy to do work. Okay, we eat pizza, we get the energy from the pizza. The food is a store of energy. So the pizza stores chemical energy. Okay. Energy is stored and then transferred. Yes. The what is used to make the pizza has a dense form of energy stored in there. And then when the person eats the pizza, the person gets the energy in order to do activities like running. So energy can be stored in different ways, and it can be transferred by heating, waves, electric current, or when a force moves an object. Example, chemical energy stored including food, fuels, and chemicals. Okay. So anytime we talk about food, fuel, and chemicals, we talk about chemical energy. Energy is transferred during chemical reactions. Energy stores, there are 5 stores of energy. Please be careful, don't mix it with types of energy. There are 9 types of forms of energy. But when it comes to energy stores, we have 5 of them. Okay. 5 stores of energy. Okay. And then if you take it further, you can break the 5 down into 8 stores. We have chemical, kinetic, gravitational potential, elastic, thermal, magnetic, electrostatic, and nuclear. Okay. Now, there is one type of energy that is a form of energy, but it's not here. What type of energy is not here? Or what form of energy you cannot see as a store? The only energy that is not a store is sound. Sound energy is not a store of energy. But the other types of energies, they store energy. Okay, they are energy stores. Okay. Now, energy can exist or can manifest in 4 pathways. It could be mechanical, it could be electrical, it could be heating, it could be radiation. Radiation is when we have light, microwave, or sound. Heating is when there's a temperature difference. Okay. And electrical is when the current flows. Mechanical, when there's an action and reaction. Force is acting on. Force is present to create energy. Okay. These are stores. So let's look at the torchlight. Okay. The torchlight has a battery that carries the current and makes it work. So here there's an energy change. So first of all, you need to look at the input energy. What energy goes into the torchlight to make it work? Obviously, is a battery. A battery stores chemical energy, and the chemical energy will be changed into electrical energy, and then the light bulb will use electrical energy and produce light and heat. Okay, so I'm going to move on to energy flow diagram in our next session. I hope this video is very useful to you, but to summarize what we've done, the first thing that I want you to know is that there are 9 forms of energy or types of energy, and there are 8 stores of energy. Energy is the ability to do work, and when work is done, energy has been transferred. Energy is measured in joules. If you have 1,000 joules, it's called a kilojoule. Hopefully, we'll meet again. This is the end of this video. Thank you. Bye.